Okay, so hello everyone. So today we're back with another question. The last two videos I took questions from competition in Singapore, but now we are going to America with this AIME question. So let's go ahead and see how to solve this very interesting question about trigonometry and also about logarithms. Okay. So we're given a function f of x, which is equal to the x squared plus 3x plus 2 to the power of cosine of pi x. We have to find the sum of all positive integers n for which this expression here is equal to 1, or the absolute value of it is equal to 1. Okay, so let's do a bit of experimenting. Let's consider this here. And to save some time, I'm just going to write log base 10 of f of k as just log of f of k. All right. So if we have log base of f of k, let's see what this is going to do. So this is equal to log of x squared plus 3x plus 2 to the power of cosine of pi of x. And so we can bring this exponent down, which gives me this expression. And then I can factor this quadratic. And this quadratic factors into x plus 1 and x plus 2. So therefore, and it can split this product into a sum. So in fact, the logarithm becomes this following expression. If I then distribute the cosine pi x. So now we have this to work with. Okay. So now that we have this, now we need to work out this being evaluated from k equals 1 to n. Okay, so how do we do this? Well, the first thing I can notice immediately is that recall that cosine of pi of x can only take two values. It can only take 1 and negative 1. And 1 is when x is, of course, even. So cosine 2 pi, 4 pi, these all evaluate to 1. However, cosine pi x will evaluate to negative 1 if x is odd. So pi, 3 pi, 5 pi, these will all evaluate to negative 1. So you can already start to sense that this could be some sort of sum where the terms start to cancel out. So let's split this into cases. I'm going to first let n be even. Okay, so that's our first case. So therefore, I'm going to write n as sum 2m for some integer m. Okay? So this is going to turn to the expression of 2m from k equals 1 of cosine pi x log of x plus 1 plus cosine pi k, and plus cosine pi k of log of k plus 2. All right, so let's write down a few terms of these series to see where this goes. Okay, the first few terms of the sums at k equals 1, cosine pi k is negative 1. So this becomes negative log of 2 minus log of 3. Then at k equals 2, cosine pi k is equal to 1. So this is simply going to be log 3 plus log 4. And then this continues on. We get negative log 4 minus log 5, so on and so forth until we reach the final term, which is 2m. Since 2m is clearly even, cosine pi k will be 1. So therefore, we will get the final terms of this expression is log of 2m plus 1 plus log of 2m plus 2. Okay, now it doesn't take a genius to see that these terms will start to cancel out. In fact, you can see here that this is very clearly a telescoping sum. And so this entire sum just evaluates to log of 2m plus 2 minus log of 2. And we want the absolute value of this sum is equal to 1. So solving this, I can combine these logs together to get log of m plus 1. And this is equal to either negative 1 or 1. Take note, however, that if log m plus 1 is equal to negative 1, you would get m plus 1 is equal to 1 over 10, which is not an integer. Okay, we need m to be an integer. So since m is not an integer, we're not going to consider this. So we just get m plus 1 is equal to 10 when we raise both sides to the power of 10. So we get m equals 9. And so n will be equal to just 2 times 9, which is 18. So we found our first solution. And now we just need to consider the second case, which is when n is odd. So we're going to let n be equal to 2m plus 1 for some integer m. And as usual, I can write down the first few terms of this expression. Since n is odd, since at k equals 1, n is still odd, the first few terms still don't change. Okay, so it's still going to be negative log 2 minus log 3 plus log 3 plus log 4 all the way to the last few terms. But since now n is odd, therefore the last few terms are also going to start with a negative sign. So we're going to have minus log of 2m plus 1 plus 1, which is 2m plus 2, minus log of 2m plus 1 plus 2, which is 2m plus 3. So this series still telescopes, of course. Everything in the middle cancels out. And so we're just left with negative log 2 minus log of 2m plus 3. And we need the absolute value of this to be equal to 1. And so clearly I can just remove the negative signs because it is absolute value. And I have this is equal to 1. And I can combine these logs. I'll get log of 4m plus 6 is equal to 1. And so take note again that log 4m plus 6 can only be equal to 1 because log of 4m plus 6, if it is equal to negative 1, I will get 4m plus 6 is equal to 1 over 10. And of course, this is not possible since m is an integer. So since m is not an integer in this equation, it cannot hold. So I get 4m plus 6 equals 10 here. So I get m equals to 1. And so therefore, n is just equal to 2 times 1 plus 1, which is equal to 3. So now that we've got n equals 3, and we've got n equals 18 from our previous work, the sum of all n's is just clearly, well, 3 plus 18, which is equal to 21. And that just happens to be the solution to our problem. Very nice.